Edexcel A-Level Maths, Pure Paper 1, June 2022, question 15. A company makes toys for children. Figure 5 shows the design for a solid toy that looks like a piece of cheese. The toy is modelled so that face ABC is a sector of a circle with radius r centimetres and centre A. Angle BAC equals 0.8 radians. Faces ABC and DEF are congruent. Edges AD, CF and BE are perpendicular to faces ABC and DEF, and edges AD, CF and BE all have length h centimetres. Given that the volume of the toy is 240 cubic centimetres, we need to show that the surface area of the toy, s square centimetres, is given by s equals 0.8 r squared plus 1680 over r, and we need to make sure we make our method clear. We're going to start by finding the areas of the different faces of the shape. Let's start with the top and the bottom, so ABC and DEF. These are sectors of a circle. Our angle is measured in radians, so we can use the formula that the area of the sector is half r squared theta. R is given as r on the diagram. We know that theta is 0.8, so it's a half r squared times by 0.8, which is 0.4 r squared. Let's move on to the faces on the side now. Well, they're just rectangles. The height is h, the length is r, so that's hr. And the only remaining different face we've got is the very end, BCFE. If we imagine that as a rectangle, it's got the height h from CF and BE, and its length, BC and EF, is going to be the arc of the sector ABC. Again, we're going to use our formula for arc length. So the end area is going to be the height h times by r theta. That's just our normal radian formula for arc length. And again, we've got our theta is 0.8. So the area of the end is 0.8 hr. Putting these all together to get the surface area of the shape, we get two lots of the ABC measurement, 0.4 r squared, plus two lots of the side, so 2hr, plus the area of the end, which is 0.8 hr. Simplifying this, we've got 0.8 r squared plus 2.8 hr. So far so good. We've got that the surface area is 0.8 r squared, which is the same as what we're aiming for, but we've got plus 2.8 hr, whereas we're aiming for 1680 over r. So we need to find a way to convert this. The first thing I've noticed is that we've got h in our answer. We need to get rid of that somehow because it's not in the one we're aiming for. And to do that, we're going to use a bit of information we haven't used yet from the question, and that is that the volume of the toy is 240 cubic centimetres. So if we can come up with a formula for the volume in terms of h and r, set it equal to 240, we should be able to find h in terms of r and substitute it in. So our toy is a prism. So the volume of the prism is going to be the area of the end times by the height. We know the area of the end, it's the sector, it's 0.4 r squared. So the volume is 0.4 r squared times by h, and as the question says, that is equal to 240. So if that is true, we can now divide both sides by 0.4 r squared. 240 divided by 0.4 is 600. So h is equal to 600 over r squared, which we're now going to substitute back into the surface area formula that we found before. So we've now got 0.8 r squared plus 2.8 r times by 600 over r squared. And looking at this, the r is going to cancel out one of the r's on the bottom of the fraction, so we'll end up with just over r. 2.8 times 600 is 1680. So we've got the formula that we needed. Surface area equals 0.8 r squared plus 1680 over r. For part B, we need to use algebraic differentiation to find the value of r for which s has a stationary point. So whenever we've got formulas and we're asked to find a stationary point, first thing we should think of is differentiation. We've got our formula for s, which is 0.8 r squared plus 1680 over r. We're going to differentiate this with respect to r. Now, just to make things easier, I like to write the fractions as r to the -1. Just makes our method for differentiating a little bit easier to see, but you don't have to if you don't want to. So differentiating this with respect to r, for the 0.8 r squared, we bring the 2 down, so it's 1.6 times r. For the second term, we bring the -1 to the front, so it's minus 1,680. Taking 1 off that power gives us -2. Now we need to find the value of r for which s has a stationary point. So a stationary point is going to happen when ds by dr equals 0. So setting 1.6r minus 1,680r to the -2 equal to 0. We want to get rid of that r to the -2 there. So if we multiply both sides by r squared, we're going to get 0 equals 1.6r cubed minus 1,680. Adding the 1,680 to both sides and dividing by 1.6, we get that r cubed equals 1,050. So cube rooting, we get that r equals 10.16. For part C, we need to prove by further differentiation that this value of r gives the minimum surface area of the toy. So there's two clues what we need to do here. Firstly, if we want the minimum, we need to differentiate again, but we're also told by further differentiation. So we know that we're going to take our ds by dr that we've just calculated, we're going to differentiate again to get d2s by dr squared. So the first term, 1.6r, nice and easy, that just becomes 1.6. The second term, we bring the -2 to the front, so it becomes +2 times, and knock 1 off the power, so that becomes -3. Simplifying this, we get 1.6 plus 3,360 times r to the -3. Now to prove that our r gives a minimum surface area, we're going to substitute that into this. So our r that we calculated in B is 10.16. Substituting that into our d2s by dr squared, we're going to get an answer of 4.8. Now to work out whether it's a minimum or a maximum, we compare this to 0. 4.8 is larger than 0. This means that it must be a minimum value of s. If you've enjoyed this video, remember to subscribe to the Doing Maths channel to keep up to date with all the latest releases.